Hello everyone. In this lecture I will discuss an important numerical technique to find out approximate roots of an equation, and that is Newton-Raphson method. It is an iterative method to find out approximate roots of an equation. So we have an equation fx equals to 0 and let x naught is its approximate roots, which is our initial guess, and x1 is its correct root. And this x1 is equals to x naught plus h, where h is a very small number. So this x1 is very near to the x naught. As x1 is the correct root, so fx1 equals to 0. And this x1 is equals to x naught plus h, and then we can Taylor expand it as fx naught plus h f dash x naught plus h square upon 2 factorial f double dash x naught, and so on. Now this h is a very small number, so we can neglect the terms that is in second order in h square and h cube. All the higher order terms we can neglect. And this fx naught plus h is fx1, and that is equals to 0, which is approximately fx naught plus h f dash x naught. So from here we can calculate h as minus fx naught upon f dash x naught. Now our x1 is equals to x naught plus h, which is nearly equals to x naught minus fx naught upon f dash x naught. So a better approximation than x naught is given by x1 by this formula, and then successive approximations are given by x2, x3 dot 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 xn plus 1, where xn plus 1 we can generalize this is given by xn minus fxn upon f dash xn. This is the Newton-Raphson formula. And we will use this formula to find out approximate roots of an equation. So now we will do some important numerical questions from previous year CSIR NET exam. Okay, so the first question is, in finding the roots of the polynomial fx equals to 3x cube minus 4x minus 5 using the iterative Newton-Raphson method, the initial guess is taken to be x equals to 2. In the next iteration, its value is nearest to A option is 1.671, B option is 1.656, C option is 1.559, and D option is 1.551. This is from June 2016 NET exam. So here fx is given as 3x cube minus 4x minus 5. So f dash x is 9x square minus 4. And the initial guess is given as x equals to 2, which is x naught. And the formula of x1 is x naught minus fx naught upon f dash x naught. So we will simply put the value of x naught. X naught is 2 minus f2 upon f dash 2. 2 minus, and f2 is 3. Cube of 2 is 8 minus 4 into 2 minus 5 upon 9. 2 square is 4 minus 4. So x1 is equals to 2 minus 3 into 8 is 24. 24 minus 8 is 16. 16 minus 5 is 11. Minus 9 into 4 is 36. Minus 4 is 32. So 32 is LCM, and 64 minus 11 is 53 upon 32, which is equals to 1.65625, which is nearest to 1.656. So the correct option is B option. Now the second question is, if the Newton-Raphson method is used to find the positive root of the equation x equals to 2 sin x, the iteration equation is A option is xn plus 1 equals to 2xn minus 2 sin xn plus xn cos xn upon 1 minus 2 cos xn. B option is xn plus 1 equals to 2 sin xn minus xn cos xn upon 1 minus 2 cos xn. C option is xn plus 1 equals to xn square minus 1 plus 2 cos xn minus xn sin xn upon xn minus 2 sin xn. And the last option is xn plus 1 equals to xn square minus 1 minus 2 cos xn plus sin xn upon xn minus 2 sin xn. And this is from June 2019 NET exam. Now the equation is given as x equals to 2 sin x. So x minus 2 sin x is equals to 0. Fx equals to 0, where fx is x minus 2 sin x. So f dash x is equals to 1 minus 2 cos x. Now from the Newton-Raphson formula, xn plus 1 is equals to xn minus fxn upon f dash xn. So xn plus 1 is equals to xn minus fxn is xn minus 2 sin xn upon f dash xn is 1 minus 2 cos xn. Xn plus 1 is equals to minus 2 cos xn, xn 1 minus 2 cos xn minus xn plus 2 sin xn. I will multiply xn, so xn minus 2xn cos xn minus xn plus 2 sin xn upon 1 minus 2 cos xn. So xn will cancel out and we will take 2h common. So in the bracket we have sin xn minus xn cos xn upon 1 minus 2 cos xn. So the correct option is B option. Now the third question is the positive 0 of the polynomial fx equals to x square minus 4 is determined using initial guess x equals to 1. Let the estimate after 2 iterations be x2. The percentage error x2 minus 2 upon 2 mod into 100%. We have to calculate is A option is 7.5%, B option is 5.0%, C option is 1.0%, and D option is 2.5%. This is from December 2019 NET exam. Here fx is given as x square minus 4, so f dash x is simply 2x, and the initial guess is given as x equals to 1, which is x naught. So from Newton-Raphson formula, x1 is given by x naught minus f x naught upon f dash x naught. So we will put the value of x naught, which is equals to 1 minus f1 upon f dash 1. Now f1 is 1 square minus 4 and f dash 1 is 2 into 1. So x1 is equals to 1 minus 4 is minus 3 upon 2. So 1 plus 3 upon 2 equals to 5 upon 2 equals to 2.5. Now the x2 is given by x1 minus fx1 upon f dash x1. And x1 we have calculated as 2.5. So at 2.5 upon f dash 2.5. f 2.5 is 2.5 whole square minus 4. And f dash 2.5 is 2 into 2.5. Now we will solve it. So 2.5 minus 2.5 whole square is 6.25, and 6.25 minus 4 is 2.25. 2 into 2.5. So by 2.5 we can cancel it as 0.9, and 0.9 divided by 2 is 0.45, and 2.5 minus 0.45 is 2.05. Now the required thing is x2 minus 2 upon 2 mod into 100%. Now x2 is 2.05 minus 2 upon 2 mod into 100%. This is 0.05 upon 2 into 100%, 5 upon 2%, which is equals to 2.5%. So the correct option is D option.